Today, I'll be presenting on one of the projects I worked on this summer, which is related to changing coastal flooding for at-risk communities in the developing world. Flooding disproportionately affects hundreds of millions of people in coastal, low elevation urban areas. Those affected often face inequalities due to belonging to specific identity groups or class statuses. That these often compound the effects of coastal flooding. Thus, our study focused on these groups of people. The picture here is a flood caused by heavy rainfall that occurred earlier this year in Maputo, and the Maputo and Gaza provinces of Mozambique, our primary study area. Flooding in coastal areas is exacerbated by the incidence of high tides, which can cause what is known as nuisance floods in low elevation areas. High tides in conjunction with sea level rise and precipitation from storms can increase the occurrence of floods and lead to disastrous effects. Yet there isn't many current flood predictive models that integrate these variables that of high tides, storms, and sea level rise. This doesn't allow for adequate planning. In order to provide policymakers who have decision-making power with necessary information, we will be using an EVDT framework developed by Space-Enabled Research Group at the MIT Media Lab to assess flooding risks, the human vulnerabilities to these conditions, as well as subsequent human decision-making and technology production or transfer. Human decision-making will then affect the environment or lead to the introduction or use of new technologies. The creation or transfer of technology will lend itself to greater environmental data. Thus, this is a flexible framework that draws from various forms of data in this sort of feedback loop that recognizes the way that various systems are informed by and impact the environment. For this presentation, I will be focusing mostly on the environmental model part of the EVDT framework. We used a package of programs developed by Rich Pawlowitz called T-Tide that performs a harmonic analysis on a given time series of tide observations. This is the formula for the equations of motion that the code output. We assessed tide observations from Maputo, Mozambique, which served as our case study in our research due to its status as being in a post-colonial state and being in a new democracy. This area is also sensitive to the effects of flooding due to its geographical location facing the Indian Ocean, as well as inequalities associated with poverty. And Maputo, Mozambique is also densely populated. This is plotted tide gauge observations from our data. We obtained our time series data from the University of Hawaii Sea Level Center. As you can see, we have some missing data, but the code still allowed us to have an accurate analysis of what was going on. We were able to predict tide levels based on the harmonic analysis of the data, which breaks the tide levels down to their constituents. Tidal constituents are characterized by the different amplitudes, phases, and frequencies that make up the resulting tide. Constituents are affected by the motion of the sun, moon, and earth. The tides are expected to follow the same pattern. Thus, we can use this analysis and apply it to the present day. This figure also matches the figure from a paper published in 2005 by Kanhanga and Diaz that studies the tidal characteristics of Maputo Bay using the same tide modeling package. And further developing our environmental model, this is some of the other work we plan to do. We'll be using space-enabled measurements to map the elevation of at-risk cities to plan flooding protections and to lead to greater resilience. We'll also be doing projections of mean sea level rise and probabilistic storm generation in Maputo will also be performed. We'll be expanding our research area more extensively to other coastal regions that are vulnerable to the effects of coastal flooding and climate change. We'll be partnering with other contacts in Maputo and conducting interviews and collaborating with other relevant scientists and key stakeholders to create strategies to mitigate the effects of coastal flooding. Thank you.